Hello, I'm King Ralph, and here is my ENME 489Y Homework 5. Let's take a look at my implementation of a smart doorbell using Python and OpenCV. Smart doorbell technology has become more popular as the buzz for smart homes has begun to increase. These doorbells typically use a camera to watch the front door of a home and will alert the user or record when motion or person is detected in its field of view. Here, I will be watching the inside of my apartment. I have the camera positioned looking at the front door. My goal is to notice when the door is swung open and someone is in view. Then I'll record a 5-second long video after that detection and email those images of the detection to myself. The flow of the code is first grabbing the image and masking it, then grabbing the second image and masking that image. Next, I'll compare the two images, and if enough of a difference is found, I'll record the video and email those images out. Here, the area that we are monitoring, here is the area that we are monitoring. And the camera has a frame of 1280 by 720 pixels. This information is needed when implementing the code. Next, we run the code on a loop, and we start by defining the mask we want to focus on. I chose to adjust the mask to focus on the area where the front door would swing open inward. This will show if something moves at the door. That mask is then overlapped on our image frame for the first and second image. Next, we blur and resize the image frame. A blur is used to reduce any high frequency noise in the image because high gradient differences in the frames are not needed to notice a change in the frames. For the blur, I used a kernel size of 21 pixels by 21. This size still provides enough detail for the algorithm to work. The image is also resized to reduce the amount of pixels that need to be scanned, and that reduction will help improve the performance. Here are the two images that triggered my smart doorbell. We see that by the second image, I have entered the region of interest, which counts as detected motion. I set a time between taking the images as 2 seconds. This is a long enough time for the person in the image to move, but not too quick so that the difference between the images can't be seen. Now, let's take a look at the detection video and then dive more into the code. As mentioned, the code works within a for loop. I start by grabbing the date and time, which is used to properly file the videos. I then capture one image, wait 2 seconds, and capture a second image. Now I apply the mask, resize, and convert to grayscale on the two images. With the images in grayscale, each pixel can have a value from 0 to 225. If we sum this value for all the pixels on both images, we can have a way to compare if the two images have changed. Now we set a threshold for the amount of pixel sum difference we need between the two images to count as a detection. I adjusted this value to 60,000. For my application, I found this value shows a change in the images and it was not caught up by any shadows or light differences in the area. Now, if a detection is noticed, I recorded the 5-second video, and after that video is recorded, it prepares to send an email. Here, I define our email message to have a subject, recipients, and a from address, and then attach the images and that message is sent out. Here is a screenshot of the email I received for this detection. This algorithm is fairly robust and works pretty well. For future improvements, I could incorporate face detection or create a way to catalog multiple videos. For my specific setup, I could improve the location of the camera to maybe give a better view of faces coming in and out. Other things that could be tweaked is by resizing the image to a smaller size. Uh, making this resize smaller could reduce the processing time needed to make a comparison between the two images. But of course, we could lose pixels to compare between both images. This was my implementation of a smart doorbell. Thank you for your time.